it's a bit different, but I think it fits a bit well in the terms of agent-based modeling and how we deal with some of the modeling aspects of it. So the outline of the presentation for this workshop is to start a bit of the context, what might be the project about, and to introduce the general waste flow standard and present some of the case studies I've been working on, and finally open up for discussions and hopefully get some good input for continuing the research. So as we all know, we are currently consuming beyond our capabilities. We have reached out of 4 of the 9 planetary boundaries. Cities are crucial for attaining sustainability, and without them, the Sustainable Development Goals will not be achieved. In this context, circular economy strategies, practices, or paradigm is identified as a positive strategy to deal and to achieve sustainability. So the research goal is to understand the role of regional planning in facilitating circular economy practices. And the idea here is that by describing and analyzing how secondary resources flow into the regions, it will be possible to explore the relationship between the spatial patterns and the resource efficiency. So through the readings and the literature and the previous literature exploration, there were certain problems identified related to that circular economy is still an infant concept, but still is trying to be used and incorporated into city planning. Urban metabolism studies and concepts lack of specialization, and geography is missing in these models. Ingestion symbiosis ideas are basically and heavily using material flow analysis, which again is lacking the spatial and geographic aspects of it. And this creates problems for urban planning and implement the circular economy ideas. And finally, there is a lack of compatibility across data and models that makes it very difficult to gain learnings from it. So this is a reflection of an illness in different parts of knowledge, which comes from the modeling aspects, from not having a proper metrics, and also at the very core is the data issues of this heterogeneous data, which is missing, or in some cases, it's even poor, or it's very highly aggregated. So in this context, smart cities can offer us and has offered in different contexts solutions and can deliver to start thinking and to help to build more sustainable cities. So the vision of this project is, as we might all be aware of, about GTPS, is the General Transport Specification, which provides a standard of how we are working with transport data. And as we have evidence in the past 20, 30 years, this unlocked an unprecedented amount of research and applications of and how to optimize transport. So if we can provide something similar for our domains, this is the value of what standards can deliver. The expansion of methods and tools to other places and to generalize ideas. So to be more concrete, the project is about developing a general model of waste flows to capture the urban metabolism processes, introduce the geographical dimension which was missing, including the location of where the activities are happening and the movement and the flows of these resources. And this eventually could be used to close the material loop and to reach higher sustainability in terms of materials. So the methodology that at the moment we are following is to, from literature, extract core concepts about resource and waste flows. Then there are consultation with experts. Then there was exploring alternatives about how to manage with this information and how it can be modeled. And then again, go back to experts and validate what we are trying to capture. move on to the development of specific cases, and finally implementing a geodatabase to move on forward to the part of simulation and scenario building. So I will try to walk you around what has been happening and what we're trying to capture, in case the audience is a bit more not so acquainted to waste flows. So in the first case, for instance, we have a person, a building or individual generating a waste material, and then it has to be transported to a container. And from that container, again, a transport is sending it, it has to be, it's moved to a storage place. For instance, this is just an example. On the bottom part, to continue with illustration, from the generation, then it's a transport, but then after the container and the transport again, there can be usage. And this is kind of the chain of reaction and the chain of flows that we are trying to model. So as I said, there were, this is happening in certain geography with certain regulations, administrations, and technology. And from there are some certain key performance indicators that are going to guide the policy and what we are aiming for, and how to assess the system, which is the end goal of this. So location, as I said, is an important part. So everything in the model will have to have a location and has to be linked to other spatial variables. So this will be the link to the build environment, to the build environment in general, but also to the environmental variables that can be found in geospatial datasets. And these are the roles of the systems that I was describing before. So we have a transportation role that an agent can have, a generation of waste. Waste can be also be storage. There is a transformation of waste, and there is also reusage of waste. And this is also an important part of the model because it allows to incorporate the circular economy aspects of it. Then we have the waste object that can be generated and these agents, depending on the role they are being active on, they will deal with different waste objects. And then we have waste that will be in a container that can be a rubbish bin on the street, or could be a more important place where a whole neighborhood drives to put bulky waste of electronics, for instance. Then we have the transportation and the route. This can be planned or unplanned. If as an individual, as a neighbor moves waste to a bulky place, then this is unplanned. But for instance, cities can have planned services of waste collection. So in this case, there's a proper route, and there was going to be a GPS collection of this. On the other side, there are also dynamic aspects that in this model, they are specified with this red triangle. So the container, it's a specific object that doesn't have any dynamic aspect, waste as well. But whenever there's an interaction or waste creation is transferred to the container, there can be log file created about what's been happening. So again, this is for waste and that is being contained, but something similar can happen with transport. And this is more similar to the GTPS and how we deal with transportation today. The red log file will contain the GPS position of the transportation or the route that is happening. Then there's a transformation dynamic. Every time from a recycling facility, we manage to transform waste for reuse, we can also create a log file. And finally, a transaction historical log that records the transaction of how many of the volume of resources that we are rescuing from this system. So this is the general idea. And in order to model the system, which is complex and also, which is a complex system that can also be defined as complicated for now, we know that agent-based modeling can be, it's a natural way of representing the system. And we know that also agent-based modeling, there are approaches to start the conceptualization and understanding the whole model as a whole, as how it works with UML, which is the Unified Modeling Language. And the idea is to start representing the whole system with this conceptualization and with this framework as a complementation eventually for the ODD protocols of how to address agent-based model. By doing this, there can be huge benefits because of the generalization of the applications. So if we know what are the data inputs and how we have to start our model, then eventually this could be replicated. And it's a step forward, but we believe it's a step forward to our openness of data and processes. So this is the class diagram, the class schema of the UML representation with all the attributes. This is a simplified version, but just to see what transportation can have. It will have an agent and ID. An agent can be a person, or it can be an industry that has vehicles, and this plays the role as a transport, and it can move from one place to the other one. It will handle a waste specification. It can be formal, it can be frequent. It can have frequency, can be programmed, can have the energy consumption, etc., etc. For the container, something similar can happen. And on violet, we can see the container log, which will have the current dynamics of that object. So how we validated this, after conceptualization of the model, we started engaging with several stakeholders. For instance, this is an image taken from a Miro board with an interview, a semi-structured interview with Kosovo region. And we were questioning if our concepts and objects in the model were sufficient, if something was missing or something was not. And then we were pinning down into specific names and actors that are in this region. And finally, we were looking what is the data that is available and how we can start taking use and making use of it. So at the moment, we have these 5 cases that we're trying to address and to capture with this with this general model, which is a semi-informal solid waste management in Buenos Aires, recycled materials in Gothenburg, municipal waste of Gothenburg, and 2 cases about industry, which can be industrial symbiosis in general or construction waste management. So just to show you about how this model can be used or how we're thinking about using it and how can be the usefulness for future simulations. In this case, we have Buenos Aires waste collection, which is a semi-formal waste collection, and they're urban waste collectors picking rubbish on site. And they mainly are collecting recyclables, such as plastics or cardboard or paper. This is arranged with the municipality, so it's a pretty much bottom-up approach with cooperatives. So you can imagine that maybe data here can be an issue and an obstacle, but things are recorded that can be an advantage of this. So I will walk you through this. For this case, what we are having in mind is that we can have different typologies of generators, such as industrial, commercial, or residents. This is just to exemplify, but there are going to be as many individuals as many blocks that generate waste. Once waste is generated, it can be aggregated, or we can have data at the building, or it can be also synthetic data, but it can be at building level, at block level, and this generates waste, which is then put in a container. And pretty much this is moving forward, and it's a more detailed example of what or how the UML example can be used. The UML model can be used. When it comes to transportation, again, the transportation cooperative as an agent will have the role also of transportation, and here they will handle the waste from one place to the other one. And just to sum up this example, in the case for the recycling facility, again, once the waste is at the recycling facility, there's a log file that eventually triggers what's the waste that's been transformed into resource, and finally, if the resource is being sold again into the market, there's another log file. So this is how we are planning to capture for the Buenos Aires case how waste is handled. Then this is the conceptual part, and later on will come the simulations and scenario building. But we believe that this is an important part if we want to start building the knowledge towards what data is required, and if someone wants to eventually pick on this model, this is a good way of structuring what has been happening. So we repeated this process for Gothenburg municipal waste of solids, for the producer responsibility of recyclables also for Gothenburg City, for a case in industrial symbiosis, and the construction and demolition system, which is an important system due to the volume of waste that is handled. Regarding the contribution of the waste, we believe that, well, the contribution is to create or to try to build a standard for waste flows of resources. The general model and the frame will hold spatial information, and that's important that it's included to understand the spatial aspects of waste handling and resources in general. Integrate the urban metabolism approach to GIS. So integrating this part is important also. And also the inclusion of the closing loops of materials it's an add-on that we are contributing with. And finally, we'll produce with the validation method, we are trying to guarantee that the main components of the systems are also being included in this. So regarding the next steps is to implement this model into a geodatabase that regarding data, worst case scenario, there's going to be synthetic data for this, but at least it will be able to show the case. We will need to identify specific KPIs for different cases and think about possible scenarios that are relevant for urban planning. And finally, start to test the scenarios and run the simulations. So regarding the workshop, will be interesting to have some guidance regarding what cases might be more important for urban planning or might be interesting to simulate, if there are possibilities of data to obtain data, and if anyone has any data sources that might know. If anyone has worked with agent-based modeling and has already built synthetic data, would be interesting to see what is the output of these models and see how this can fit in our standard. And there's also potentiality for integration with digital representations of cities. And finally, regarding implementations, we are still in early stages, but start to think which will be the best tool to handle this sort of simulation that we are having in mind. Thank you very much, and thank you for listening. And now it's open for questions. Thanks, Michael.
Timing. Please formulate any questions if you have them, and if you don't want to formulate them live, you can also use the chat box. Whoever has any questions.
Well, at this stage, it's only the